Hello everyone, welcome to iitiansgateclasses. So in this session we are discussing DGCA 2023 UPSC ASO exam solutions. So this is for set B and this is for theory of plate and stress analysis. So in DGCA UPSC ASO exam they mention syllabus as theory of plate and cells. So I believe it should be theory of plate and the application should be in civil. That should be the syllabus title, because after going through all the questions what I understood, they may have kept these subjects for constructing airport runways and all, because most of the questions are related to civil construction, mainly for how to idealize those civil structure in terms of plate. And then there are some questions on stress analysis. So it is not on experimental stress analysis. The questions are on numerical stress analysis also. So I changed the title as stress analysis. Now, if you go through questions, so first question, what it says, consider the following statement regarding finite element method for continuum structure. So, guys, finite element method FEM is used for numerical stress analysis, and continuum structure means it's a continuous linearly elastic structure. So what first says, in finite element method, a coarse idealization involving number of large elements would provide a comparatively rapid but very approximate solution. Yes, if you use the elements in idealization of large size, you will get poor solution, very poor solution. Okay, but the solution timing will be less. So is the first is correct answer. In finite element method, a fine idealization involving number of elements would provide a comparatively very approximate solution. So fine idealization, number of elements would provide a very comparatively very approximate solution. Again, let me read here what it says. In a finite element method, a fine idealization involving number of elements. So I think it was written number of large. Let me see in the actual paper. It should be not be a typo here. Question number 10th. What it was actually. Yeah. So here actually there is a typo in option 7, option second. It should be in a finite element method of fine idealization involving a small. So actually when the fine idealization is used, then the number of elements will be more. So it is not correct. And it gives approximate solution. Of course, it will be approximate solution, but better solution. So whenever there is a fine mesh, the number of elements will be more. So 2 is not correct. What third says, in finite element method, graded meshes are used in which small elements are placed in region where high stress concentrations are expected. So this is correct. Usually, the area of interest where fine mesh is used, so small elements are used in fine meshes, and those areas where the stresses are less, so there can be used large elements. So option 3 is correct. So ideally for this question, so 1 and 3 is the correct options, correct sentence, and C is the correct answer. C is the correct answer. Now read the next question what it says. Quadrilateral elements are frequently used in combination with which the following elements to build a particular geometrical set. So guys, quadrilateral elements is a 2D element, okay, in finite element, and it is the most commonly used element, okay, for idealization of any skin or panel. So tetrahedral, if you take, it's a 3D element. Hexahedral is a 3D elements, and rectangular elements cannot be used with quadrilateral. Quadrilateral means it will have 4 edges. The element can have any aspect ratio. So along this quadrilateral element, the best combination is 2D elements, triangular element. You can see this is how mesh can be created. Okay, so this is for 2D meshing. So C is the correct answer, triangular elements. If you see next question, so this is the first questions from theory of plate. Okay, what it says, what is the primary characteristic of the foundation in the context of plates resisting on an elastic foundation? So if you see, this is how idealization, when there is a plate where the loading is sitting on elastic foundation, so base will be rigid base. So this is how approximation is done for this problem, and you can see this is what the reference. So rigid is the answer, rigid base will be there when elastic foundations are used. So read next question, what it says. What are the three key assumptions for obtaining a better approximation of subgrade behavior in the case of core and subgrade? So guys, first we need to understand what is the subgrading. So usually in road constructions and other places, the foundation is made rigid. So that is known as subgrading, because your foundation cannot like we cannot allow deformation easily to foundation. Okay, or we cannot give the elastic property to foundation, so its upgrading is done. So when foundation is rigid, so out of four you can see only one case where foundation is rigid. So you can see option B, where foundation is rigid. So the plate is heavy and plate is floating, but still I'm not sure because I'm not civil expert. So B should be most appropriate answer. Foundation cannot be soft. Foundation should not be semi-elastic, infinite elastic also, and foundation is frictionless is also not a correct. I'm not sure about A much, but B should be the most appropriate answer for question number 77. Now, question number 78, what it says, in which type of machine parts are circular plates of non-uniform thickness commonly found? So guys, this is one of the question, you can say again related to plate, but application is in aerospace structure. So usually these diaphragms of steam turbines and pistons of reciprocating engines are of circular plate of non-uniform thickness. So for this, you guys can see the reference provided here. Circular plates of non-uniform thickness are sometimes encountered in the design of machine part, such as diaphragm of steam turbines and piston of reciprocating engine. So what should be the answer? B should be the answer. Now look into next question, what it says. What shape typically mount plates used as floor slab for skew bridges? So guys, in case of the skew bridges, usually oblique parallelogram bound plates are used. Okay, because skew bridges, the property of skew bridges are like that. You can see the angle will be less than 90 degrees. So you can see here skew is less than 45. Here skew is greater than 45, but you can see these are the parallelogram types. Okay, so you can see single span deck. Okay, so oblique parallelogram. Next question. What is the primary purpose of studying stress distribution around a hole in plate? So usually we want to see around hole what is the stress concentration, because we know in structure whenever there is a sudden change in area there will be high stress concentration. So to understand how stress concentration around holes is the primary purpose of to find a stress distribution. Okay, so C is the answer for question number 80. Next question, what it says. Why is it suggested to consider a very large plate when investigating stress distribution around a hole? So to increase the accuracy of the result, usually what happened, these edges, if your plate is small and having a hole and we are doing investigation for stress, then what will happen, this edge distance will affect stress distribution on the hole. So it is better very large plate is used to increase the accuracy of the result. So this is what the answer D. Yeah. So what is the transit time for typical carrier and adhesive combination in the context of strain gauges? So this question is from properties of strain gauges. In syllabus, they have mentioned is experimental stress analysis. So in experimental stress analysis, there are different method. Strain gauge is one of the method, but they asked a question from properties of strain gauge. So it is answer is B, which is 15 nanosecond. And you can see here, this is the reference from one of the lecture provided by Professor his name, he's from Dayanand Sagar University, Dayanand Sagar Engineering College, Bangalore. His name is Gowda. Currently, I have forgotten his name. So, what it says, the transit time which is given by T equal to H by C2 and equal to 50 nanosecond for typical carrier and adhesive combinations. So, B is the correct answer. Now, what is the last question? What it says? What is the main advantage of uh, cyno cyanoacrylate adhesive commonly employed in strain gauge application? So usually these adhesive will cure at room temperature. So C is the answer, without heat or catalyzed. So C is the answer. Okay. So that's all from this part. So thank you all for watching this session. No, there is one more question. Question number 98. So it is easy question, and it is again can say either aircraft structures basics, or you can say stress analysis, where basics are there same. So what it says, what is the term used to describe the angular change between two line segments that were originally perpendicular? So usually if you take a stress element and we say the change in angle between two perpendicular plane is what shear strain developed in the element. That is what the definition. So what is D is the correct answer. Okay, so the change in angle, this is like suppose this is theta 1 and this is theta 2, and so this will be pi by 2 minus uh, gamma. So gamma is what shearing strain. It is theta 1 plus theta 2. And again, I can say this is one of the questions from IGC lectures and material provided to our students. Okay, so there is more, no other question, I believe. Yeah, there are questions. Yeah, so this is one of the question where I will say the answer is YTD, yet to decide. And I have done a good amount of research. I couldn't understand what this question mean, what it says. What, no, sorry, I'm very sorry, not about this question. This is a simple question. It seems I am in hurry. So read the question first, what it says. This is well defined question and we can answer, not this question. What happens to the middle surface of a plate when it is bent to a non-developable uh, developable surface? So guys, if you take the plate and if it is subjected to bending, what happens to mid surface? What happens to mid surface after bending? There will be no change in length of mid surface. and the strain at mid surface will be 0. So it will become neutral surface. But it what option A says, because some people answered option A is not correct, it remains unchanged. Remain unchanged means there is no change in curvature. But what happened? This is the original. But when it is bending, the when plate is bending, this neutral surface will also bend. Okay, will also bend, but strain along neutral surface will be 0. So it will this neutral strain along this mid surface will be 0, so it behaves like neutral surface. So answer D is correct. Yeah. So actually, there are questions more. I was thinking about some other question. We will discuss that once that comes. So, what is the primary purpose of beams in building construction? So, usually beams carries what? Bending loads. So beam distributes loads to support. That is the main purpose. This lateral stability is usually provided by column. Okay. Enhancing insulation, no. Insulation is enhanced by mainly floor. Okay. Aesthetic design, no. So the primary function of beam to carry distributed load or to carry bending loads. And this you can see, if you see one simple structure of building, then you can see this is a beam, and so it distribute loads to these supports. So these are supporting column. So usually column have structural instability issue. Okay, so this provide the lateral stability. Column provide lateral stability. Yeah, read next question what it says. Which type of support is commonly used for the exterior walls in the building construction? So basically the exterior walls should have strong supports. Okay, so the strongest support is what? Fixed support, because you can see many times your exterior walls have the extension over that, some extension of the structure also. So usually this support should be fixed support if it is a external wall. So the entire floor weight also will be going to external wall, and external wall should have strong support. So it is a fixed support. Now read the next question. What it says: what is the primary function of floor slabs in the building? So if you take floor slabs, you can see all these are function of floor slab, but what is the primary function? Is the main function is to provide structural support. Okay, but it enhance insulation, yes. To distribute electrical wiring, yes. Along the floor slabs we will see the wiring also done to serve as a decoration. If aesthetics are done on floor slabs, you will see decoration like false ceilings and all. So A is the answer. Yeah, so this is what the question I was talking. What is the primary characteristic of a plate structure that is symmetrical with respect to a center? So, first I tried, but usually plates we use for lateral loading. So, B can be the most correct answer. Rotational loading, no loading, vertical loading, how it is related with symmetry of the plate. Okay, so I'm not sure about this question number 5, but it's still, if UPSC decide, B can be the answer or maybe D is the answer. For that I need to do more academic search. So that's all from session. Yeah, so thank you all for watching this session. So if you guys have any question, be free to ask in YouTube chat. And if you guys have any concern regarding any of the question, be free to discuss in our Telegram group, or you guys can freely comment below this session. Okay. And now we have completed the solution for all 20 question. No, still some flight mechanics aero related questions are there. We will do tonight, and IGC key is ready. Tomorrow we will release them. Okay. So thank you all, and thank you all for watching this session. All the best.